There's a pattern comets follow when they enter our solar system. It starts with a long, arcing approach. They accelerate as they near the sun, shedding ice, venting gas, trailing particles. Then, after perihelion, the closest point to the sun, they slingshot outward, gradually fading into the void. 3i Atlas was supposed to follow that script. It didn't. In the weeks leading up to perihelion, the data made sense. It entered the system at hyperbolic speed, just like Oumuamua in 2017 and Borisov in 2019. Initial modeling showed a steep departure angle, steep enough that by December, it would be outbound and fading fast. A one time visitor, no return, no threat. Astronomers from Hawaii, Chile, Spain, and Australia locked in their predictions. Trajectory models showed the same elegant curve in, around, and out. The escape path was clean, too clean to question, but by the time December 4th arrived, something didn't add up. The arc had shifted, slightly at first, then dramatically. Instead of accelerating away from the sun, 3i Atlas began to slow. The first teams to notice were dismissed. Instrument error, data lag, solar interference. But the readings persisted from different telescopes across different hemispheres. It wasn't drift, it was deceleration. And more than that, it was curvature. Instead of maintaining its hyperbolic exit, Atlas had begun to bend inward. Its velocity vector no longer pointed toward the stars. It was curling back into the system. That kind of shift isn't natural, not at this scale. Comets can deviate slightly. Outgassing can introduce irregular motion, but the forces required to redirect a body of this mass at this speed aren't subtle. They leave traces. There were no jets, no brightening, no plume. The coma had collapsed, the tail had faded, and still the object moved, but not along its expected path. It moved inward, with control. Simulations broke. One by one, the major orbital models failed to match observations. The hyperbolic arc, once stable, dissolved into chaos. Orbital fitters began seeing new possibilities, sub-hyperbolic curves, bounded trajectories, encounters, but the direction was worse than anyone had predicted. The path was flattening, not escaping the solar system, Avadai, but re-entering its interior. Jupiter was still nearby. Its gravity always distorts passing objects. So the first explanation was gravitational capture. But even Jupiter's pull can't account for the type of maneuver Atlas executed. To fall back in, that tightly requires precision, not random perturbation. Then came the second anomaly, the timing. The course change wasn't gradual. It happened in a specific window, a narrow 2-hour period when the object exited solar conjunction and came back into view. Right as sensors locked back on, the curve was already bent, the acceleration profile already altered, the escape trajectory already gone. What happened in the blackout? What moved it? The odds of natural outgassing producing a maneuver that mimics spacecraft level correction are infinitesimal. It would require jets firing in a precise vector at a precise interval with no visible material. It doesn't happen, and yet it happened. Today, Atlas is no longer leaving the solar system. It's moving inward, not randomly, not tumbling. It's locked into a new path, and that path ends near Earth. What looked like a one-way traveler has become a returning body. But it's not the comet that made that decision. It's whatever redirected it. And that decision, that moment, is where this story begins. It didn't arrive with a flash. There was no broadcast, no signature trail, no violent motion across the sky. It was just there, not because it entered the system, but because it had never left. Long before anyone noticed 3i Atlas drifting off course, a faint anomalous thermal signature had been quietly recorded by deep sky infrared arrays. The reading was dismissed. It didn't match any known comet, asteroid, or spacecraft. There was no motion, just a fixed, low heat presence,
near the outer edge of Jupiter's gravitational field. Then came the first whisper of curiosity. An observatory in Chile saw a shallow interference pattern in the far infrared band. Nothing dramatic, nothing publishable, but strange. The signal didn't shift with Earth's rotation. It didn't wobble with atmospheric distortion. It stayed centered, fixed in the sky, locked in a frame just beyond Atlas's projected path. And then came December 4th. Atlas began to slow. Its escape trajectory flattened, and in the same segment of sky, the infrared pattern changed. A long, tapering arc began to appear in the background, cooler than surrounding space, devoid of reflection, but with motion, deliberate, slow, consistent. Theta had not been detected because it hadn't needed to be. It wasn't bright. It didn't emit. It absorbed, like a ghost in the data, a mass without visibility, a presence without light. When astronomers cross-checked the vectors, the truth became harder to ignore. This wasn't a companion object joining the comet. This was an independent body that had been holding a mirrored orbit for weeks, maybe longer. The spacing was exact. The velocity delta remained constant. No drift, no chase, just shadowing. Theta was matching Atlas's trajectory from behind, 240 kilometers back, with precision that shouldn't be possible for anything natural, not a random rock, not a gravitational coincidence, not a lucky alignment. This was calculated, and it wasn't just the path. The spacing between the two remained consistent, even as Atlas began its shift. As it slowed, so did Theta. When Atlas dropped below escape speed, Theta followed the arc. It wasn't responding. It was guiding. The shape of Theta, when finally visualized through deep stacked exposure by the SOHO spectrometer, didn't match anything familiar. Not spherical, not tumbling, not fractured, angular, dark, stable. A triangular silhouette with an asymmetrical core mass, showing no tail, no coma, no fragmentation. Comets fragment, debris fields rotate, asteroids tumble. This didn't. What moved behind Atlas was not a cousin, not a twin. It was something else entirely, and it had already been in place before the story even began. One by one, observatories began pulling their long-range filters back to reprocess historical data. They found traces, weak echoes, subtle thermal bleed, gravitational ripple. Theta had been there for at least 17 days, positionally locked, phase matching Atlas with engineering-level accuracy. And it didn't come from outside the system. It was waiting. There's no public model for that kind of behavior, not in comet science, not in interstellar dynamics. Nothing we've cataloged so far can explain an object that shadows another with no delay, no deviation, and no signal, and yet that's exactly what Theta did. It didn't accelerate into place. It didn't adjust to Atlas. It was already there, matching its movement, holding a fixed position behind it, like a guide rail no one could see. Now both bodies move in sync, and for the first time since its discovery, Atlas is no longer alone. But the most important part of this alignment isn't how Theta moves, it's how long it's been doing it. Because if it's been tracking Atlas since before we noticed, then it wasn't reacting to Atlas. It was waiting for it. There's a moment in every event when reality begins to bend, not all at once, not dramatically, but quietly, just enough to make the data hesitate. And this time, that hesitation came in the form of a single question: what's moving it? Because by the time astronomers realized 3I Atlas was no longer on a stable outbound trajectory, the cause was already behind it, in motion, unseen, and completely unexpected. That moment of the pull was subtle. There was no flash, no spin-up, no sudden disintegration. The orbital fit simply failed. One by one, tracking stations began reporting divergence, not drift, not chaos, but a smooth, controlled deviation from the predicted arc. At first, teams blamed the usual culprits: solar wind, instrument lag, outgassing, but the vectors didn't align and the numbers didn't lie. The pull wasn't internal, it was external. Still, no one saw it coming because there was nothing to see. The background remained dark. Theta hadn't revealed itself yet. No coma, no trail, no heat bloom, just influence. It was the orbital plots that noticed first. Minor changes in delta V, subtle velocity adjustments that couldn't be accounted for by internal forces. Too clean, too stable, too directional. Natural jets from comets don't fire like that. They erupt randomly. They wobble the spin axis. They vent material and scatter light. But Atlas did none of those things. Its spin smoothed, its velocity shifted, and its course curved, not chaotically, precisely. That's when analysts started revisiting historical data, looking not just at where Atlas was, but what it passed by. Infrared residuals from earlier in the month showed a cold anomaly, a patch of sky near Atlas's vector that absorbed more background radiation than expected. Again, the assumption was instrumentation, ghost signals, sensor echo. But the pattern repeated over 3 separate nights, across multiple observatories. Still, no one connected it, not until December 4th, when 3i Atlas stopped escaping. The pull, the moment everything changed, lasted less than 2 hours, but its precision was undeniable. Theta didn't appear in the sky, it appeared in the motion. And that was the shift, because for months, everyone was watching Atlas. No one was watching behind it, not the instruments, not the data analysts, not the mission directors. The assumption was singularity. One object, one trajectory, one anomaly. But Atlas wasn't alone, and it hadn't been for some time. Once the gravitational influence became measurable, Theta's presence went from invisible to inescapable. You could ignore the missing tail. You could dismiss the quiet coma. You could explain away the odd acceleration. But you couldn't ignore the shift in course, because comets don't turn on command. They don't phase lock to unseen companions, and they don't fall into new orbital regimes without being pushed. Whatever Theta is, it wasn't just close, it was engaged. And its first act of influence wasn't contact, it was redirection. Astronomers now believe that the moment we first noticed the change in Atlas's velocity wasn't the beginning of interaction, it was the end of the setup. The invisible hand had already reached out, already corrected the arc, already begun the capture. We just didn't know what we were looking at because we were watching the wrong object. We were following the wrong mass. We were modeling the wrong system. Atlas was never moving alone. It was already in orbit around something we hadn't seen. And once it pulled, no one could look away. Orbital mechanics is supposed to be predictable. That's the entire point. You measure an object's position, calculate its speed, factor in gravity, and the math tells you where it's going next. Not in theory, in certainty. We send probes to planets using these equations. We track asteroids years in advance. We predict flybys down to the second. And 3i Atlas followed that same logic until it didn't. For months, the models worked. Trajectory simulations matched real-time data. The comet was outbound, fast, stable, leaving the system. But then the numbers began to slip. At first, it looked like noise, a few micro-arc seconds off, a slight mismatch between prediction and observation. But with each pass, the error grew, small at first, then sharp, then impossible to ignore. By the time December 4th arrived, none of the models held, not NASA's, not
S's, not the independent ones run by amateur astronomers across the globe. Everyone was watching the same object. Everyone was running the same math. And every single prediction failed. The simulations didn't just misfire, they collapsed. 3-body calculations produced unstable spirals. Gravitational fitters couldn't lock down the center of mass. Solar radiation pressure models overshot the curve. Cometary outgassing simulations couldn't account for the velocity change. One by one, every trusted tool in the orbital toolkit stopped working. And that's when the questions began. What's forcing the motion? Where is the external input? Why can't the curve be reproduced? Because this wasn't like Borisov. It wasn't like Oumuamua. This was something new, a breakdown not in theory, but in expectation. In one simulation lab, researchers added artificial variables just to see. One team introduced a low thrust, constant vector from behind the comet. Suddenly, the model snapped into place. It fit perfectly, too perfectly. The match wasn't just close, it was precise. The arc tightened at the exact moment it did in real space. The deceleration mirrored real telemetry. The rotation matched observed spin lock behavior. And the acceleration source, it didn't come from the comet, it came from somewhere else. But that opened a new problem: justification. Because orbital models don't assume intelligent propulsion, they assume gravity, solar radiation, momentum, and in the case of comets, gas pressure from sublimating ices. But Atlas wasn't outgassing, it wasn't tumbling, and it wasn't spinning freely. The physical inputs didn't exist. The measured behavior couldn't be explained, not by natural forces. Theta hadn't even been confirmed yet. Only the thermal anomalies had been seen, so researchers did what they were trained to do. They forced the model, they adjusted reflectivity, they inflated the comet's mass, they added asymmetric gas jets, but the fit kept failing. The simulated path spiraled outward, the real object spiraled inward, so they tried again, this time with an invisible mass, one position behind the comet, holding pace, applying minimal force. The model stabilized. Once theta was introduced as a silent, non emitting gravitational partner, everything locked into place. The pull made sense, the curve matched, the deceleration aligned. Even the spin correction could be accounted for by minor torques. But the conclusion was uncomfortable because now they weren't modeling a comet, they were modeling a system. Two bodies, one visible, one hidden, bound not by gravity, but by influence. And no one had the tools to explain what kind of natural object could do that. By the end of the day, most simulations were shelved, unusable, incorrect. The comet was still there, but the rules it was supposed to follow weren't. In the quiet between calculations, one truth settled in. This wasn't just an anomaly. This was the moment orbital science stopped being predictive and became reactive because the models had broken and the thing moving Atlas didn't follow equations. Once the models broke, everything went quiet, not because the data stopped coming, not because the object disappeared, but because no one knew what to say. In astronomy, silence is usually a pause before discovery, a breather, a moment to reassess. But this was different. This silence wasn't the absence of answers, it was the presence of something no one wanted to explain. Within hours of the failed trajectory models, updates from ground based observatories slowed to a crawl, public telemetry feeds lagged, trajectory prediction maps froze in place, and email chains, usually full of banter and debate, went dark. The few analysts still sharing observations weren't theorizing, they were asking questions, uncharacteristically careful questions. Has anyone rerun the last 6 hour arc? Do we have confirmation from the second polar station? Is that a software error or something else? And then came the oddest shift of all. Requests stopped being shared publicly. They started going private. Spectral data, once available through open university portals, now required special credentials. Timestamps began disappearing from shared documents, and tracking pages that once showed second by second comet movement started showing nothing, just static labels, old paths, outdated curves, the kind of freeze that doesn't happen by accident. In astronomy circles, people began to whisper about delays, that missions were told to hold off on public briefings, that raw data was being redirected to different servers, that even minor observatories were asked, not ordered, but asked, to shift focus away from the object. It wasn't censorship, It was vacuum, the kind that only forms when the air gets pulled out of the room quietly, methodically, and with intent. Meanwhile, Atlas kept moving. So did Theta. But official commentary did not. NASA's Minor Planet Center, usually quick with updates, published nothing new. The ESA's Near Earth portal stopped showing comet telemetry altogether, and major astronomy news outlets shifted to other stories. Suddenly, the most unusual object in the solar system, the one that had just defied every model, became uninteresting. But the silence wasn't just external. Even inside the professional community, something had shifted. Collaborators stopped emailing. Peer review requests were withdrawn. Scheduled conference talks were canceled or renamed. The discomfort wasn't in what was seen, it was in what couldn't be explained. How do you publish a paper about a gravitational companion that leaves no light trail? How do you submit a model with a non emitting object applying course correction torque? How do you describe a pull that happened without visible force? You don't, not yet, not until someone bigger speaks first, and no one wanted to be the first. The silence wasn't avoidance, it was strategy. Because once someone confirms that 3i Atlas isn't moving on its own, that there's something else beside it, that this companion was already there, then every other question follows. Where did it come from? How long has it been here? And what is it doing now? Until those questions have safe answers, silence feels like the only response. But it wasn't just silence in speech, it was silence in signal. Atlas's radio band remained dark. No spike, no burst, no carrier wave. Theta didn't emit, didn't echo, didn't scatter. Together, they formed the quietest anomaly in modern observation, a comet that stopped being a comet, and a shadow that never introduced itself. By December 4, the instruments still worked. The skies were still clear, but the silence wasn't just between people. It was between signals, between questions, between the comet and whatever was behind it. There's a point in every visual data set where motion becomes form, not pattern, not prediction, but shape. And when the deep frame stack from Chile came in, that shape broke everything. It wasn't supposed to be there, not in that frame, not at that scale, and definitely not with those edges. The data came from a multi hour exposure sequence, multiple stacked frames, filtered through thermal variance layers to eliminate noise. Standard procedure. But what wasn't standard was the result, because instead of a comet alone in a black sky, instead of a fading streak across the stars, the final stack revealed something behind it, broad, flat, structured. They called it the frame, not because it enclosed the comet, but because it looked like one, rectangular, faintly arched along the horizontal, and anchored, visually anchored around Atlas like scaffolding you couldn't see in real time. Every time the frames were stacked, it appeared. When individual exposures were viewed, it was gone. That shouldn't happen. Cosmic rays? Nope. Atmospheric interference? Ruled out. Stacking artifact? That's what they wanted to believe until it aligned on three separate data sets from three separate observatories, each one captured from a different continent, each one processed independently, each one pointing at the same part of the sky, and each one showing the same structure, the same outline, the same silent geometry, a faint glow surrounding Atlas, but never moving with it, almost as if the comet was inside it. This isn't something that happens with natural objects. Comas expand, tails shift, jets flare and wobble, but this structure was static. Even as Atlas curved, the frame held, like a picture locked in place while the subject inside it shifted slightly. It made no sense, and the questions multiplied. Was it an illusion of contrast, an unknown light scatter, a reflection echo from solar interference? But the glow didn't.
React to solar position. It didn't fluctuate with comet brightness, and it wasn't present in areas outside of Atlas's motion vector. It was local, centered, always with Atlas, and yet not part of it. When analysts plotted the alignment in 3 dimensions, the frame's shape formed a shallow half shell, not behind, not in front, but around, a soft envelope of non-emission that mimicked the perimeter of a spacecraft's thermal shroud, except it wasn't real, at least not in any conventional sense. There was no emission spectrum, no particulate density, no thermal contrast beyond ambient, just presence, a boundary without substance, a shape without mass, an edge without matter, and yet it was there, over and over. What made it worse was its consistency. Most lens artifacts fade with exposure time. They flare, they bleed across wavelengths, but the frame stayed tight, 1 pixel wide, arc consistent, non-diffusive. That's when people stopped calling it an error. They didn't call it a craft, not yet, but the word enclosure began showing up in footnotes. Perimeter signal, symmetric field bloom, polite terms, careful ones, because if you admit there's a structure holding around Atlas, then you have to ask who built it or what. The frame couldn't be explained by comet physics, couldn't be accounted for by background noise, and couldn't be separated from the object without losing the signal entirely. It was either part of Atlas or part of something holding it. Neither answer gave comfort, because one meant the comet was changing in ways no one understood, and the other meant it wasn't the comet at all. It was cargo, and whatever formed that frame, whether heatless scaffolding or masking envelope, it wasn't accidental. It was engineered, or at least aligned. And in the data logs from that night, 3 words were written by an analyst who didn't know what they were seeing, but knew enough to be afraid of it. This is positioned. Comets are supposed to behave like passive objects. They follow light, they reflect solar wind, and when they get close enough to the sun, they grow tails, long, luminous streaks pointing away from the light source. But 3I Atlas didn't just defy that rule, it reversed it, and the moment it happened, observers knew they weren't looking at a natural reaction anymore. At first, the anti-tail of Atlas was seen as a curiosity, a faint stream of material that pointed in the opposite direction of the main tail. These are rare, but not unheard of. Dust particles shaped by orbital dynamics sometimes create optical illusions that seem to flow toward the sun instead of away from it. That's what astronomers thought they were seeing, an illusion, a temporary alignment. But then the anti-tail grew sharper, stronger, more defined, and worse, it began to rotate. Images from 3 separate ground-based stations confirmed what no one wanted to believe. The anti-tail was not only real, it was repositioning, not drifting, not fanned by radiation, but reorienting against the solar vector. And then came the inversion. Within less than 2 hours, the dominant tail flipped. What was once a standard solar-facing tail became the secondary stream, and the anti-tail took over, now pointing directly toward the sun. This wasn't just unusual, it was impossible. Tails don't decide where to go. They respond to physics, but this one ignored it. The inversion didn't coincide with a solar flare. There were no magnetic disturbances, no micrometeoroid impacts, no rotational wobble from the comet itself. Atlas didn't spin, didn't tilt, didn't eject material to account for the change. It just realigned, as if something else had taken control of the tail's direction. The brightness map made it even stranger. Normally, a comet's tail diffuses as it grows, fainter edges, wider spread, a softening as particles lose cohesion, but Atlas's anti-tail tightened. It became narrower, more linear, and carried a spectral signature that didn't match known dust or ion compositions. Infrared readings showed a cold zone forming inside the new dominant tail. Instead of heating from solar radiation, the tail seemed to absorb energy. The closer it got to the sun, the darker it became. And in that darkness, no emission, no particle reflection, just a hollow strip of shadow. aimed like a pointer. Then came the radio silence. As the tail inverted, the usual static hum, the electromagnetic scatter every comet carries, went quiet. Spectrographs recorded a clean band. No noise, no flare. It was as if the tail wasn't made of material anymore. It had become directional. Engineers from one observatory compared it to a plasma lens, not in the sense of optics, but in structure, a field of influence shaped to control signal behavior. Not light, the inversion coincided with the moment Theta's trajectory merged. From that point on, Atlas no longer behaved like a single object. Its emissions, movements, and tail all responded in concert. Some believed the anti-tail was awake, a byproduct of Theta's movement. Others thought it was a shield, a decoy, but one interpretation kept surfacing in private circles. It was communication, not in language, not in data, but in geometry. A silent gesture from one object to another, it's saying, "We are locked." Because no natural comet in recorded history has ever reversed its tail into the solar wind and held it steady. 3I Atlas did, and it didn't even flicker. The closer a comet gets to the sun, the hotter it gets. That's not theory, it's physics. Ices sublimate, dust jets erupt, thermal signatures spike. Every recorded comet follows this rule. Every one except 3I Atlas, because even as it dipped into the inner solar system, even as it entered the zone where comets light up, Atlas stayed cold, not cool, not moderate, cold, infrared. Arrays from multiple stations in Hawaii, the Canary Islands, and South Africa all reported the same readings. Low thermal output, no localized hotspots, no gradient consistent with solar heating. It didn't make sense. By all visual measures, Atlas looked active. Its coma held, its tail had structure, but in thermal bands, it was muted, barely warmer than the background sky. For weeks, researchers blamed the instruments. Maybe the calibration was off. Maybe the data was corrupted. But then the James Webb Space Telescope locked on, and it saw the same thing. An object that should have been glowing in the mid-infrared barely emitted anything. Surface temperature modeling failed. Gas detection algorithms found no spikes. The usual markers of active cometary behavior, carbon monoxide, water vapor, hydroxyl, didn't register above noise level. Even as Atlas neared its closest solar approach, its heat remained fixed, unchanging, almost artificial. The silence in the data was too consistent, too exact. Thermal readings showed a tight band of uniformity across the entire visible structure. No heat bleed, no outgassing flare, nothing to suggest a natural body warming under solar pressure. And then came the clincher, a comparison with Comet Encke, which had crossed a similar trajectory at a similar distance, revealed a thermal contrast ratio more than 20-fold. Encke burned bright. Atlas didn't burn at all. It was as if the object was resisting temperature change. Some scientists proposed high albedo materials. Maybe the surface was reflective enough to bounce solar energy, but that doesn't explain the thermal void around the tail, or the lack of emission from gas pockets, or the consistent temperature across irregular surfaces. Others whispered about internal regulation, that Atlas might be harboring a shell, a skin that equalized exposure, not rock, not ice, but some unknown compound or structure that kept heat in or kept it out. Then the ESA's thermal dispersion models came in. The shape of the thermal boundary wasn't random. It followed angles, hard edges, lines that looked more like geometry than geology. There were even thermal valleys, colder than the surrounding space, that seemed to rotate in sync with the object's slow spin. That's when people stopped calling it a comet, at least in closed circles, because no comet stays cold that long, not under that much exposure, not while accelerating. There's always a flare, always a loss, always a moment where heat wins. But Atlas never had that moment. Its heat curve remained flat. its emissions never bloomed, and its surface signature never cracked. One observatory in Spain described it as thermally disciplined. Another team at Caltech called it temperature locked. But the simplest description came from a low-level researcher analyzing data in real time. It's like it's not absorbing the sun at all. And that's what changed everything, because heat is the great revealer. It betrays movement, it exposes function, it reveals life or the absence of it. But when the heat signature stays cold, it means one of two things. Either the object is lifeless beyond recognition, or it's controlling the narrative. 3I Atlas didn't burn, it didn't warm, it didn't glow. It passed through sunlight with the indifference of something built to ignore it. And in that quiet defiance, it told every telescope watching, "You're not going to see what you expect." It began with an anomaly, not a visual one, not thermal, but acoustic in the language of space. Radio telescopes aimed at Atlas to monitor potential electromagnetic emissions started hearing echoes, not signals, not pulses, but subtle fluctuations in the noise floor, rhythmic, almost musical, but buried deep in the static. The first to catch it was a team in northern Australia using a low-frequency array to scan background noise across interplanetary bands. They weren't even focused on 3I Atlas directly. They were mapping Jovian auroral reflection patterns, but at two specific points in the scan, a repeating echo emerged, a wave within the wave, consistent, balanced, oddly placed. They backtracked, recalibrated, and pointed directly at Atlas. The pattern didn't get stronger, it got cleaner. The signal-to-noise ratio stayed low, but the shape of the pattern stabilized. 3 pulses, a flat line, then 2 shorter modulations, and then silence. It repeated every 4 minutes exactly. They submitted the data upstream. At first, it was dismissed. Ambient interference, perhaps, or ground-based reflection, but then a facility in northern Chile working on an unrelated L-band project reported the same pattern, not stronger, not louder, but perfectly in phase, thousands of kilometers apart, same delay, same structure, same silence in between. That's when the term echo became official, because it didn't originate from Earth, and it didn't reflect off anything we know. It came from the direction of Atlas, but not from Atlas itself. Spectral isolation showed the emission was not point-based. It didn't radiate like a burst. It resonated as if bouncing within a larger, invisible chamber before spilling out weakly into detectable space. It wasn't just noise, it was geometry, and that scared people. Astronomers began running positional overlays, mapping the origin path of each pulse based on triangulated lag. The strange result? The pulses didn't come from the core, not from the coma, not from the tail, but from behind, far behind, roughly 12,000 kilometers off Atlas's path, in a zone no object had been cataloged. A blank zone, no visual readings, no thermal detection, just signal echo. That's when the whispers about Theta returned, because if Atlas wasn't alone, if there really was a companion, then maybe these weren't echoes at all. Maybe they were pings, the kind you send when locking position, or checking alignment, or waiting for a reply. Except no reply ever came. Just the same pattern again and again. 3, flatline. 2, silence, repeat. Even when the object passed into denser solar interference, the pattern held, unchanged. Attempts to jam the frequency, or at least isolate it, failed. The echo adjusted. As one researcher put it, it wasn't trying to be heard. It was just happening. There were no harmonics, no harmonization with known background emissions. It sat alone, pure, mathematical, which meant two things. It wasn't natural and it wasn't random, but perhaps the most chilling realization came from a software engineer tasked with visualizing the pattern in 3D. After plotting over 70 full cycles, the resulting waveform didn't spiral, it didn't curve, It built a shape, a tetrahedral lattice, stable, precise, three-dimensional, as if the echo wasn't just sound, but structure. No one had an explanation because echoes imply space. Space implies boundaries, and boundaries imply something solid enough to reflect. There was nothing solid there, at least nothing we could see. Just three-eye Atlas passing forward and something else behind it, staying quiet but never still. When an object tumbles through space, it tells you everything about its mass, about its shape, about what forces act on it. That's how we know when something's natural or not, because natural objects drift, wobble, precess, but artificial ones, they lock. And on the 4th of December, Three Eye Atlas locked. It started subtly, no sudden flare, no spin up burst, just a gentle pause in its irregular light curve, a flattening that shouldn't have been possible that deep into solar proximity. At first, it looked like a timing glitch, a data sync error between observatories in Namibia and New Zealand. But when orbital analysts lined up the readings second by second, they realized the dip was real. The wobble was gone. The comet, once drifting unpredictably, now rotated on a single, stable axis. No torque, no drift, just rotation, locked. Normally, comets don't behave this way. Even stable ones have minor spin irregularities due to outgassing. Jets cause shifts. Dust clouds redistribute mass. But Atlas showed none of that. Its jets had quieted, its structure remained visually intact, and yet its rotation had become perfect. Every 7.2 hours, the same face turned to Earth. Every 7.2 hours, the same tail arc repeated. It was surgical, like something had taken over its spin and trimmed the slack. No known mechanism could explain this. No outgassing was strong enough or clean enough to cancel torque that efficiently, and gravitational forces from the sun would only worsen the instability. But Atlas was getting smoother. The light curve flattened into a clean sine wave. Infrared markers from its surface aligned. Jet activity, already low, ceased entirely.
Spin lock is not just rare, it's unheard of for interstellar bodies. Objects from outside our solar system are chaotic by nature. They carry histories we don't understand. They arrive fragmented, drifting, broken. But this one arrived spinning and then chose to stop. And that's what changed the analysis entirely. Because locking isn't a passive event, it requires correction, input, energy. Theories began to circulate. Maybe it was the influence of another gravitational body, Theta again, or maybe it wasn't a comet at all. A shell, maybe, hollow, symmetrical, a casing that could be stabilized because the timing of the lock matched perfectly with the anti-tail inversion. Chapter 7 had shown that Atlas reversed its tail toward the sun, something no comet does, and now it wasn't spinning freely anymore. It was presenting, one face toward Earth, one orientation held through light and shadow, no random drift, no loss of control. When planetary defense simulations tried to model the spin, they failed. Their inputs assumed a natural structure, inconsistent mass, irregular density, asymmetric surface, but the data from Atlas showed the opposite. Even density, flat mass response, no inertial drift, a perfect body in motion. When this kind of stability appears in satellites, we call it station keeping. When it appears in comets, we have no term because it shouldn't exist. One scientist from the Lunar and Planetary Institute described it best. We're not watching a comet spin. We're watching something maintain face, because spin lock doesn't just say stable, it says intentional. And when an interstellar object locks its face toward you, when it quiets its movement and narrows its tail, you're no longer observing a traveler. You're observing something that has noticed you, something that's now holding its posture, waiting, watching, aligned. They were tracking it, all of them, from Arizona to Chile, from Tenerife to Mauna Kea. Every scope that had line of sight kept one eye on Three Eye Atlas and the other on the expanding void behind it, the zone where Theta was suspected to exist, but no one saw it approach. There was no flare, no reflected glint, no thermal bloom, just an empty space, and then a correction in the distance. It didn't happen instantly, it happened quietly. One moment Atlas was alone, then the next, the parallax measurements were off, just by a margin. Then they shifted again and again. It wasn't Atlas that had moved, it was the reference point behind it. Something was closing in. It didn't emit light, it didn't reflect it, and yet mass was present. Gravitational lensing confirmed it. By mapping the distortion of background stars, the European Southern Observatory traced a curvature, slight but undeniable, that bent light around an invisible core. That curvature was moving. Every 12 minutes, the arc bent slightly deeper, and every 12 minutes, the object behind Atlas drew closer, except it didn't reveal itself. It remained black, not just dark, black, an absence, a subtraction from space. Infrared couldn't see it, UV couldn't ping it, radar returned nothing, yet it was there. The only way to measure its proximity was to watch Atlas react, and Atlas was reacting. Its trajectory didn't shift, its spin remained locked, but the structure around it began to deform. The anti-tail narrowed again, the coma compressed, and most tellingly, the light scatter from its surface dropped. It was being eclipsed, shadowed by something the sun couldn't pierce. One astrophysicist called it the cleanest non-reflection I've ever seen. Another called it a shadow without a caster. But it was real, and it was closing the distance without announcing itself. Models ran simulations of natural objects that could match the behavior. Rogue asteroid? No. Too much spin, too many reflections. Collapsed gas cloud? No. Those glow under compression. Primordial black hole? No. This didn't distort gravity enough. What matched was something with mass but no thermal footprint, something that canceled light across multiple wavelengths, something that didn't absorb but redirected. That's when the term mask began to circulate, not as metaphor, as structure, something that traveled alongside Atlas, trailing silently behind, and now moved into alignment. And with every hour, the light from Atlas dimmed, not from distance, but from obstruction. The shadow wasn't growing, it was sharpening. Edges appeared, straight ones, too perfect for dust, too precise for debris. This wasn't a natural occlusion, it was placement. Something was positioning itself directly between Atlas and the observational line, and not just Earth's view. The shadow matched even from oblique angles, from Mars orbiting scopes, from heliocentric instruments. The blackout was coordinated. It meant only one thing. Whatever was behind Atlas, it didn't want to be seen, not yet, but it also didn't flee. It moved forward with no propulsion, no light trail, no disturbance, just silent, smooth approach until Atlas was no longer the brightest point in the field, until Atlas no longer led its own path, until the thing behind it, the thing that gave off nothing, reflected nothing, revealed nothing, had closed the gap, and there it sat, not visible, but undeniable, a presence that closed the distance without leaving a single trace of light behind. Light bends when it passes near mass. That's how gravitational lensing works. It's how we detect galaxies too distant to see directly. And it's how we proved black holes before ever seeing one. But what happened behind Three Eye Atlas wasn't lensing, it wasn't distortion, it was architecture. Because when the invisible mass behind Atlas passed into alignment with the sun, the resulting shadow didn't behave like a comet's would. It locked.
Clean, hard-edged, and consistent. And that's not how shadows behave in space. Cometary bodies scatter sunlight. Their comas diffuse it. Their tails disperse it. But here, the shadow wasn't diffused. It was defined, measured in real time by ESA's heliocentric probes and confirmed by spectrographs at Cerro Paranal. The object behind Atlas cast a void, a silhouette that remained unchanged as the viewing angle shifted. No diffusion, no elongation, just one steady geometry, a hexagonal arc, perfect symmetry, flat planes, not curves. That was the first break in the silence. Because nature doesn't do flat in space. Not like this, not in cold, dusty, interstellar debris. But even more concerning than the shape was the rate at which it moved. The shadow held its geometry even as it crossed layers of plasma density, solar flare interference, and atmospheric distortion. It didn't ripple, didn't flex, didn't shimmer. It simply slid from one side of Atlas to the other, not in orbit, but in lockstep. A few researchers tried to model the shape using assumptions from solar occultation data. They expected a general blur, an irregular core with uneven edges. What they got instead was a solid model, fixed angles, repeating ratios, and something else. Not only was the geometry precise, it responded, because when the James Webb Telescope switched bands and increased its exposure for deeper analysis, the geometry shifted, not in form, but in angle, a fractional rotation. And when a Canadian-based observatory shifted its polarization, the object compensated, as if to keep its minimal cross-section, as if it was minimizing its profile. Shadows aren't supposed to do that, but this one did. A synchronized adaptation across instruments, angles, and bandwidths. And the alignment wasn't random either. It aligned with the path of least interference, Earth's observational corridor, as if it had mapped where we were watching from and adjusted accordingly. This is when the word proximity left the realm of theory. We weren't looking at something distant anymore. We were seeing something present, right there, just behind Atlas, sharing its orbit, sharing its momentum, but casting a shadow all its own. The light curves from two observatories, one in Japan, one in Argentina, showed matching drop-offs, a clean notch at exactly the same timestamp. When synchronized, the shadow geometry laid perfectly over each other. No drift, no parallax error. It was a perfect match from opposite sides of the Earth. This meant one thing: the shadow wasn't projection, it wasn't illusion, it was real. There was volume, there was orientation, there was intent, because nature can cast shadows, but it can't maintain angles. This thing did, and in doing so, it told us something we didn't expect. 3i Atlas wasn't being followed. It wasn't being intercepted. It wasn't being observed. It was being escorted, and the object doing the escorting was close enough to cast geometry, but still disciplined enough to stay dark. It was close, too close, and now we weren't measuring a comet. We were measuring the shape of its companion by the only thing it let slip: its shadow. Umbra is not just a shadow. It's the deepest part of one, the region where light is completely blocked, where no rays leak through, where visibility ends. It's a term we use for eclipses, for planetary occlusions, for events with known geometry. But now it was being applied to something we couldn't see at all, because the moment 3i Atlas and the companion object reached full alignment, something unexpected formed between them, and around them a field, a cone, a dimness. It didn't behave like a shadow cast by one object onto another. It wasn't sharp. It wasn't geometric. It was soft, but total. An umbra that stretched outward in both directions, behind the companion and forward around Atlas, like a curtain folding around the pair. First noticed by a spectrographic anomaly in southern Chile, the light drop-off wasn't immediate, it was progressive. Stars in the background dimmed as the pair passed, not just blocked, but scattered in an oddly consistent gradient. And then, once the core passed, they reappeared, but with lower intensity, lower color temperature, and less clarity. It was as if the space around the pair had taken light in and refused to give it back the same way. That's when the European Space Agency tried narrow angle polarization mapping, a technique usually reserved for analyzing planetary rings. What they saw forced them to escalate the classification. The entire region, not just the two objects, but the field around them, was distorting incoming starlight. It wasn't simply being blocked, it was being processed, because inside this umbra, nothing was just dark, everything was different. Photons bent, angles skewed, even background radio noise warped subtly as it passed through. The void wasn't hollow, it had substance, and not in a gravitational sense, in an optical one. Some called it a field, others a membrane. But what no one could deny was that this umbra wasn't cast by one object. It belonged to both, like a shared boundary, a mutual halo of absence, which meant something critical. They weren't two objects in formation. They were one system, connected, orchestrated, possibly even bonded, because natural bodies don't generate shared umbra. Even binary asteroids cast overlapping shadows, not merged ones. Even twin stars don't create conical zones of filtered light. But here, the region wasn't just darker, it was changed. Infrared measurements inside the zone dropped to near baseline, even when Atlas itself was illuminated by solar angles. That shouldn't happen. There was enough heat bouncing from the coma to illuminate dust, enough solar energy to excite particles, but in the umbra, nothing responded. No scatter, no echo, no bounce, like space had thickened. It didn't absorb, it erased. One researcher put it like this: imagine throwing a flashlight into a fog, and the fog doesn't glow, it swallows it. And the strangest part, the shape of the umbra remained consistent across all observational latitudes, whether viewed from Earth, orbital telescopes, or solar side monitoring stations. Its structure held. That implies something even more chilling. This wasn't a side effect of angle or flare. It was intentional. The zone around Atlas and the object behind it wasn't just dark, it was maintained, as if whatever existed between them wasn't just moving through space, but curating how it was seen, or more accurately, how it wasn't. So now we're not just observing a comet or a companion, we're observing a veil, a mutual silence. And as they approach the inner system, that silence isn't fading. It's deepening, because light no longer escapes cleanly, not from them, not from around them. Inside the umbra, the universe goes quiet. Every time something strange happens in space, scientists turn to simulation. It's how we predicted planetary motion, how we tracked Oumuamua, how we model near-Earth object threats, comet fragmentation, solar eruptions. Simulation is the bridge between observation and understanding, but not this time, because when every model was asked to recreate what was happening between 3I Atlas and the unidentified object trailing it, they all failed. It didn't matter what parameters were fed in: size, mass, reflectivity, orbital drift, gravitational shear. All were tested. Every simulation collapsed. Some spun out of control in the first 5 seconds. Others generated physically impossible results, like tail reversal without mass ejection or spin lock during angular acceleration. And some did something even worse. They produced nothing, a null result. No prediction, no motion, just a system frozen at initial conditions. That never happens. Even the most exotic objects, black hole binaries, rogue interstellar clouds, yield at least a mathematical behavior, but not this. It was as if the simulation engines refused to project what couldn't be natural. And they were right. The main anomaly wasn't the comet, it was the interaction. Atlas by itself could be loosely modeled. It didn't follow standard comet physics, but its path was traceable until the moment the object, now known as Theta, entered proximity. After that, everything broke. NASA's Jet Propulsion Laboratory tried adaptive mesh refinement models, the most advanced tools they have for real-time orbital mechanics. They simulated millions of particles interacting with solar wind, radiation pressure, and tidal forces. Still nothing matched. Not the anti-tail behavior, not the spin lock, and certainly not the Umbra. ESA went further. They built new gravitational hybrid models, combining Atlas and Theta as a possible binary system. They ran 1 trillion iterations. No stable formation emerged, no shape that held, nothing that explained the precise geometry of the shadow field. But the worst failure came from thermal simulation, because thermal behavior is usually predictable. An object that moves closer to the sun should heat, it should radiate, it should glow in infrared, but Atlas didn't follow that rule. Theta didn't follow any rule. Thermal modeling showed no increase, no decay, no conduction. Even when placed in direct simulated solar flux, the object returned no believable thermal profile. It remained silent. This led some teams to introduce speculative variables: active shielding, optical masking, heat redirection, even artificial surface modulation, all of them science fiction, none of them resulting in viable simulations. Then came the structural analysis. When the clean-edge shadows were fed into light diffraction software, the shapes wouldn't blur. They remained intact through simulated distortion, as if they weren't being made by rough materials, but by engineered edges. And that's when one astrophysicist asked a question that shouldn't have been necessary. Are we simulating physics or intention? Because nature doesn't correct. It doesn't maintain stable planes, suppress heat, synchronize shadows, or mute radar. But something was, and the only consistent outcome across all simulations was this: if you remove natural turbulence, if you remove randomness, if you remove entropy, only then does the model hold. In other words, only under control. That's not a comet, that's choreography. And our tools aren't broken, they're just not built to model decisions. So the failure of every simulation didn't just leave a gap in our understanding, it revealed something deeper. We weren't seeing something that could be calculated. We were seeing something choosing not to behave like anything we've ever tried to simulate, because 3i Atlas isn't acting alone and Theta isn't reacting at all. They're both executing something that was never meant to be reproduced by the human mind. For months, every lens was pointed at 3i Atlas, the coma, the tail, the trajectory. Astronomers debated its classification. Was it a hyperbolic interstellar comet? Was it debris from an unknown solar system, or something stranger? But all along, the real question was hiding in plain sight. What if the comet wasn't the object? What if the comet was the disguise? Because something began to shift in the data, not from Atlas itself, but from how it behaved when Theta came closer. Its coma compressed, its tail narrowed, its spin locked. At first, these anomalies were brushed aside. Outliers, environmental variance, data noise, until something subtle but terrifying became clear. The comet's visible structure was responding to something else, not solar wind, not thermal flux, not gravitational shear. It was reacting to proximity. The behavior made no sense unless you accepted one idea, that Atlas had never been the central mass. It was an accessory, a flare trailing behind something else. And when you reverse the lens, when you model the observed light, not as a mission, but as interference, the pieces begin to fall into place. Light that should have reached us didn't. Spectra that should have shown reflection returned silent, as if Atlas was diffusing light around a core that wasn't its own. Imagine a fog bank drifting through space, but at the center of that fog, a vehicle, something designed not to be seen directly. What better way to approach an observing civilization than hidden in the form they already expect? A comet fuzzy, unpredictable, naturally chaotic, and completely unthreatening. That's the genius because no one fears a snowball. And while every institution on Earth mapped the dust tail, logged the outgassing, debated the origin curve, Theta was already beside it, not hidden behind it, integrated into it, and that integration goes deeper. Radiation pressure, usually enough to subtly alter the path of a typical comet, had almost no measurable effect on Atlas. The surface didn't flake. The gas jets didn't shift the course, almost like it wasn't volatile matter at all, but a skin, a shell, and one that began falling away the moment Theta entered observational alignment. That's when the coma began to change color. The tail shortened, spectral density thinned. It wasn't depleting, it was shedding, as if the outer layers had served their purpose, as if the disguise was no longer necessary. And behind that veil was structure, not debris, not porous rock, but flat angles, repeating reflections, the kind you don't find in natural objects, the kind you only find in engineering. The moment this hypothesis began circulating, a second round of analysis was initiated. Old images were reprocessed, photometric data was reinterpreted, and a new pattern emerged. The light curve of Atlas wasn't random. It was rhythmic, not rotational like a tumbling rock, but pulsed, timed, coordinated, as if signaling, as if blinking. And it wasn't Atlas doing it. It was Theta using the comet as a shroud until it no longer needed one. Which raises the question, if Atlas was the cover, what exactly is Theta covering? And more importantly, why now? Because the moment the light patterns changed, the object began to maneuver, not drift, not fall, move. And all the data suddenly pointed to one conclusion no one wanted to say out loud. We weren't observing a comet entering the solar system. We were watching something enter disguised as a comet, and now the disguise is falling away because the show is over. The cloak is unraveling, and the thing underneath it has finally decided we're ready to see it. Or worse, that it no longer needs to hide at all. The Lagrange point known as L2 is one of the most stable locations in near-Earth space. It's quiet, predictable, shielded from the sun by the Earth's mass, perfect for deep space observatories like the James Webb Space Telescope, perfect for instruments that require thermal isolation, minimal interference, and unobstructed views into deep time. It's also supposed to be empty. Apart from our telescopes, monitoring stations, and a few calibration satellites, nothing drifts there, nothing natural stays, because for all its orbital harmony, L2 has no mass of its own. It's a balance point, a plateau in a gravitational field. But on the morning of December 4th, that balance shifted. Telemetry from ESA's Lagrange monitoring satellite, placed specifically to track minute deviations near the L2 region, recorded an anomaly, a pulse, subtle but unmistakable. Something entered the L2 corridor without disturbing the instruments. That's not possible. Every object, no matter how light, registers gravitational interference. Even a chunk of ice from a failed satellite causes minor variance. But this wasn't variance, it was cancellation. The sensors registered less than nothing, a negative curve, like gravity itself was being edited. At first, they assumed error, drift, timing misalignment, until NASA's Deep Field Probe Sentinel-I-3 also pointed near L2 for calibrating faint object detection, caught the same thing, a silence, a black patch, a zone where photons should have returned, but didn't. Again, not blocked, erased, like a hole had opened in the star field, but there was no flare, no heat, no reflection, and yet there was mass. The slight orbital drift of the Webb telescope confirmed it. Its positioning thrusters activated preemptively, an automatic correction usually triggered by gravitational nudge. Something was exerting influence, but not from far away, from right beside it. That's when observers finally overlaid the models of 3I Atlas and Theta. onto L2's path, and the truth hit harder than any theory could explain. The alignment wasn't accidental. Theta's trajectory, now increasingly decoupled from Atlas, passed directly through the Earth-Sun L2 corridor, a path no comet should take, a path no random object could hold, and yet it held perfectly at the exact moment when the umbra around Atlas deepened and the spectral noise around Theta dropped to absolute silence. L2 shifted. And then something stranger happened. For just under 90 seconds, every instrument aimed at L2 experienced a measurable delay, not in data acquisition, not in packet return, but in light. Stars behind L2 flickered, not in brightness, but in timing. Their photons took longer to arrive, just enough to register, just enough to prove something was there, not blocking space, folding it, and whatever that was. It didn't stay in L2, it paused, then moved toward Earth. No orbital spiral, no slingshot, no deceleration curve, just a drift, slow, purposeful.
Direct. Theta had separated. Atlas continued its descent, but Theta had taken station, used L2 as a stepping stone, a waypoint, a pivot, and the field it left behind remained active for almost 9 minutes, long enough to reshape our entire understanding of what had just entered our system, because nature doesn't use Lagrange points like that, but navigators do, positioning does, strategy does. And if Theta chose L2, it means it knew where we place our eyes. It knew what to mimic. And more than that, it knew where not to be seen. Until now, because on December 4th, the silence broke, and the one place in space designed to hide our eyes from the sun was used to hide something else entirely. L2 is no longer empty, and the thing that was there is no longer still. When astronomers lose visual confirmation of an object, they turn to radar. Radar doesn't rely on sunlight. It doesn't care about reflection, phase angle, or albedo. It sends a signal out and waits for the echo to return. That echo tells you everything: distance, surface texture, motion, composition. It's the cleanest method we have for knowing if something is really there and exactly where. But when Goldstone sent a radar ping toward Theta, the echo didn't come back on time, not late by much, not enough to trigger alarms, just enough to make the technicians pause. Milliseconds, a blink. But in physics, especially interplanetary physics, milliseconds are everything. They mean something didn't follow the rules. At first, the signal delay was dismissed as interference, solar activity, angular misalignment, atmospheric scatter. All were ruled out. Then came the second test, another pulse, this time using a different angle, different timing, different frequency, same delay, and not just a delay, a distortion. The echo came back, blurred not in strength. The signal was strong, but in shape. A radar return from a comet usually contains subtle spread, a soft, broken reflection caused by surface dust and irregularities. Theta's echo wasn't soft. It was hollow in the center and sharpened at the edges, like the signal had hit a shell, a structured boundary, and worse, and the center band of the radar return didn't match the departure pulse. It was missing data, not jammed, not blocked, redacted. The wavelength came back clean but incomplete, like the object had read the signal and decided what part to reflect. This forced Goldstone into a rare third phase protocol. They sent an unmodulated pulse, pure carrier, no encoded signature, a move typically reserved for uncooperative targets, and this time the delay doubled. The signal returned in a clean arc, but clearly offset. By then, the Naval Space Command had already begun observing. Their deep sea listening posts, tied into long range radar networks, registered something far stranger. The returning signal wasn't just distorted in time, it was distorted in location. The
Source of the return appeared to originate slightly behind Theta's projected position, as if the signal had bounced off something else, not a surface, not dust, but a shadow object, an echo of mass, a form invisible to optics, but not to frequency, a form traveling with theta, but offset by several kilometers, like a secondary body, or a projected signature. Either way, it wasn't natural. No comet deflects radar with that precision. No ice fragment sends back a clean shell with controlled timing variance. This was deliberate, and with each new ping, the returns became less coherent, less predictable, until finally one of the low-frequency pulses triggered something no one expected, a counterping, not a reflection, a generated return, distinct waveform, distinct rhythm. The signal came back in a perfectly clean sine pulse, smoother than any known echo. And it didn't match the outgoing pulse. It was new, crafted, as if something out there had received the signal and decided to send back its own. And yet the delay remained, still milliseconds, still consistent, almost like a buffer, a pause, a gap, as if something was thinking, because natural bodies don't hesitate, but intelligence does. And in that delay, in that space between our question and its answer, lies the most terrifying silence of all, not the absence of data, but the presence of a choice. Every major space anomaly follows a protocol. Data is collected, preliminary reports are shared, agencies coordinate to avoid overlap, duplication, or panic. After that comes the debriefing, a closed-door session where senior scientists, intelligence analysts, and institutional representatives break down what happened and what to do next. It happens every time: when Oumuamua passed through, when Voyager entered interstellar space, when a Chinese satellite blinked out over the Pacific for 9 seconds. Even false alarms get a debrief, but not this, not after Theta detached, not after the radar delay, not after the signal that shouldn't have returned. Instead, silence. Worse than silence, disconnection. Emails between observatories timed out. Auto-syncing servers at the Deep Space Network went out of phase for a full 11 minutes. 2 separate observatory clusters, one in the Canary Islands, the other in northern Chile, flagged identical checksum mismatches in encrypted communication with NASA. The data was still there, but the conversations stopped. There was no scheduled conference call, no interim review, no internal briefing pack, not even a placeholder summary. Instead, internal Slack channels at the Jet Propulsion Laboratory were archived with no explanation. Private Git repositories used to store predictive trajectory code were locked behind new access tokens. A flight path visualizer on the European Space Agency's public-facing site was quietly under maintenance for 36 hours, all standard operations. If something massive
had occurred, but there was no announcement, no internal bulletin, no scheduled debrief, just a vacuum. Some researchers assumed the meeting happened without them, that only senior tiers were briefed, that a new clearance level had been imposed. But as the days passed, even those with top-tier access saw nothing, no update, no directive, no denial, only silence. And yet actions spoke louder. Scheduled flybys of unrelated comets were delayed. 3 upcoming planetary imaging missions were suddenly reprioritized. The James Webb Telescope's December calibration run was overridden by a non-disclosed observational target, which just happened to be located precisely near the Earth-Sun L2 point, the same place where Theta passed through. That wasn't coincidence. It was reaction. Reaction without context, without communication, because if there had been a debriefing, even one behind closed doors, there would be traces, calendar blocks, security overrides, flight bookings. There were none, and yet changes kept happening. NASA's internal Q3 roadmap was redacted. SETI's signal analysis team received a Department of Defense liaison. Private observatories were contacted by unnamed data quality inspectors asking about light curve anomalies in sectors they hadn't even reported. It wasn't a cover up, it was worse. It was fragmentation. The system that usually absorbs shock, the coordinated institutional net of modern space infrastructure, simply dropped the ball or let go of it. And when individual researchers asked for clarification, they received auto replies. Your request has been forwarded. Due to increased demand, response time may vary. Inquiries regarding deep space object classification are currently on hold pending review. Review by whom? No one knew. Even insiders with direct links to mission control teams at Goldstone and Canberra noticed a change in tone. No jokes, no speculation, just short replies, often ending in ellipses. Yeah, we saw that echo. Still processing. Trajectory curves are flatlining. Something's weird. No scheduled ops next week. They told us to stand by. The words that never came were louder than the ones that did, because if a real debriefing had happened, the kind where decisions get made, where findings get shared, then the community wouldn't feel like this, disoriented, cut off, waiting for a page that never loads. Instead, they're left with one chilling thought: what happened after Theta passed was big enough to silence the entire network. And the debriefing didn't happen because someone decided it couldn't. It's called the ecliptic, Earth's orbital plane, an invisible disk cutting through the solar system, tracing the path our planet follows around the sun. Most celestial objects, planets, moons, asteroids, even comets, tend to move near or along this plane, not because they must, but because the forces that
shape our solar neighborhood pull them there over time. But some objects don't play by those rules. 3I Atlas was one of them. At first, it entered at an angle, sharp, declined, the kind that suggests deep interstellar origin, the kind that doesn't care about the organization of our system. It was one of the reasons scientists initially ruled it non-threatening. Its inclination was high. Its path would veer below the ecliptic, but then it changed after Theta detached, after the spectral silences, after the radar distortions and the blackout around L2. The object began to climb. Gradually, almost imperceptibly, its trajectory adjusted, not from external forces, not from gravitational pulls or thermal venting. It adjusted itself, and the adjustment wasn't random. Theta began to level out. Its approach vector, once steep and evasive, began to arc gently toward the flat plane of Earth's orbit, the very ring we ride around the sun every year. And on the morning of December 4th, that intersection happened, not a close pass, not a deflection, a clean, calculated penetration of the ecliptic. It wasn't the path of an interstellar visitor. It was the path of intentional alignment, because intersecting Earth's orbital plane isn't just a coincidence. It's targeting geometry. It's where orbital dynamics become tactics. Satellites use it, probes use it. Anything that wants to match velocity with Earth needs to enter the plane we travel on, and Theta did exactly that with precision. Data from ESA's Gaia Observatory, which constantly monitors star positions and near-Earth object paths, confirmed the shift. Over the course of 6 days, Theta's path flattened out by almost 1 full degree. That might sound small, but in astronomical terms, it's surgical. No known natural process could flatten a comet's approach like that in such a short time without massive energy loss or fragmentation. But Theta didn't lose mass. It didn't fragment. It stabilized. And when that orbital plane intersection occurred, something even stranger followed. A drop in background gamma radiation, localized to the section of sky directly opposite the sun, not Earth's magnetosphere, not solar shielding, a gap, as if something had passed through the zone we normally interpret as quiet and left behind. even more quiet, like a shadow sliding into alignment. In the hours that followed, multiple satellites triggered automatic tracking algorithms. Objects tend to reflect infrared, scatter UV, or absorb X ray. But Theta's signal didn't behave that way. It mimicked our satellites, blended with background telemetry. For one window, less than 12 minutes, NORAD's orbital tracking system tagged Theta as a geosynchronous object. That's not possible. You don't go from a deep space interstellar trajectory to matching Earth's orbital plane unless you plan to, unless you know how to. And Theta did, which means that whatever its origin, whatever its purpose, it's now moving with us, orbitally synced, plane matched, no longer a visitor just passing through. Now it's something else, a shadow in our orbit, a presence sharing the same solar rhythm. And it didn't drift here. It chose this path, which begs the question, if Theta is now on our plane, how long until it's over our skies, or worse, already is? For weeks, the story was about 3I Atlas, the visible, volatile, dramatic body we thought we understood, and Theta, the darker, quieter, more structured presence that revealed itself slowly, like something waiting for the right moment to move. Two bodies, one interaction, one trajectory bending into mystery. But that changed, not with a flare, not with a radar hit or a JWST detection. It changed in silence again, and this time it came from below. Amateur observatories in the southern hemisphere were among the first to notice it, nameless at first. Just a subtle distortion in the background light curve, a smudge, a displacement, too symmetrical to be dust, too slow to be noise. The initial assumption was a sensor error, faulty calibration, camera condensation, or light bleed, but then it repeated across different cameras, different filters, different locations, and always in one spot, offset from Theta by a precise arc, moving not away, but alongside, trailing but not random. NASA didn't say anything at first, nor did ESA, but the timing of their internal query pings, the way observatories suddenly requested southern sky time, told the truth before any press release ever would. They'd seen it too, and it wasn't debris, it wasn't ejecta, it was coherent, structured, self-shadowed, and it wasn't small. Compared to Atlas, it was dimmer. Compared to Theta, it was colder. But in mass profile, it fit. Same density banding, same absence of tail or flare, and most alarmingly, the same rotational stillness. Theta's lack of spin was already a red flag, but now, this new object, quickly labeled as Sigma, matched it. Sigma didn't tumble, didn't drift. It held orientation, even as it adjusted its trajectory to stay in lockstep with Theta. That's when the modeling teams broke silence. An internal simulation at the Lunar and Planetary Institute was leaked, not officially, but quietly, passed through informal channels. It showed something impossible. 3 objects now forming a triangle, moving in relative balance, with Atlas still out ahead, shedding material and light like a diversion, while Theta and Sigma flanked behind it in synchronized positions, a formation, not a cluster. And that's when everything changed, because now the theory of randomness was dead. This wasn't a captured object, not a hitchhiking comet fragment, not an accidental pairing. This was an intentional arrival, and more than that, a sequence. Atlas was the spectacle, Theta was the shadow, Sigma was the third, the balance, and that balance wasn't perfect. It responded. When one moved, the others compensated. Their spacing fluctuated slightly, but always returned to equilibrium. No gravitational slingshot, no chaotic drift, no natural turbulence, just silent, steady geometry. And all 3 shared a common element. They ignored the sun. Comets accelerate near it. Fragments react. Structures warm. But Atlas, Theta, and Sigma showed no thermal reaction, as they neared the solar influence. Instead, they cooled, passive by profile, but orchestrated by behavior. And here's what really chilled the teams monitoring them. The third object, Sigma, didn't arrive late. It was already here. Radar logs stitched together after the fact showed low signal returns near Earth's orbital plane, returns dismissed as noise or atmospheric scatter, but matched against Sigma's emergence vector, they were consistent. It had been hiding, or worse, cloaked by Atlas's coma and Theta's vector shadow. And now it had stepped forward. 3 bodies, 3 angles, 1 path, and Earth unknowingly, directly in their convergence corridor. Because with Sigma's arrival, everything shifted, not just the science, the implication. This was no longer a strange object passing through. This was a configuration, a system, and systems don't form by accident. From the start, it was all about the comet. 3i Atlas glowing, fragmenting, screaming through the void like a messenger from beyond. It lit up the sky. It triggered every early warning system. It became the obsession of astronomers and theorists alike. It was the showpiece, but somewhere along the way, something felt off, too bright, too fast, too willing to be seen. It had all the hallmarks of a classic long-period comet: hyperbolic orbit, intense outgassing, dramatic tail formation, and yet none of it added up. Its core didn't behave thermally. Its coma formed too early. Its light curve followed no standard decay model. Still, it was the object in the headlines. It was the one space agencies tracked, the one satellites were ordered to follow. But behind the scenes, the real attention shifted, first to Theta, then to Sigma, then to something else entirely. Because if you look back, really look, the story of Atlas is one of distraction. It gave us data, but data we were meant to see, all while something more structured, more coordinated, more deliberate was unfolding in its shadow. The moment Sigma appeared, everything recontextualized. Atlas was bright, but not alive. It spun, it fractured, it ejected gas, but it never responded. Theta and Sigma, they reacted to positioning, to radar, to each other. They weren't tumbling ice, they were controlled. And when their synchronized geometry locked into a fixed triangle, you could feel the shift. This wasn't a comet encounter. This was the slow reveal of something much larger, something that didn't want attention at first, that used Atlas as a veil. And that veil worked. While we chased light signatures and tail formations, the real bodies moved into position, silent, invisible, and cold. And when they intersected Earth's orbital plane, it was no accident. It was convergence, which is why the phrase interstellar comet no longer fits, because Atlas wasn't the threat. It wasn't the signal. It was the disguise. Every major movement, every vector shift, every blackout zone, every ghost radar return points to one thing. Atlas was never the mission. It was the decoy, a fragment deployed in advance, bright enough to pull our eyes, chaotic enough to seem real, fast enough to overwhelm our models. And once it entered the solar system, it did its job. It announced the arrival, with drama, with spectacle, with noise. Meanwhile, the real mission slipped past us, quiet, unlit, precise. Theta and Sigma were never secondary. They were the core. Their alignment wasn't coincidence. It was choreography. And the more you study the timing, the more it becomes undeniable. Atlas entered first, not to lead, but to draw fire. By the time our instruments locked on to the deeper geometry, it was already too late. The pair had crossed into our system. They'd passed L2. They'd matched Earth's plane. They'd stabilized formation. And every motion after that, every radar bounce, every optical ghost came not from a natural body, hurtling through space, but from an operational event unfolding in low visibility. It's why the public data streams thinned, why internal briefings were canceled, why the best observatories in the world started sending coded requests for raw signal access instead of published summaries. They saw it too. Atlas was the mask. The mission is what came with it. And that mission, it's still here, still moving, still aligned. And if Theta and Sigma are behaving the way they seem to be, then the real question isn't what 3i Atlas was, it's what it let in.